Okay, so I've got two 26 tubes installed here now to replace the one that had the open filament and to replace the 45. And I've also got another one here in the box as a potential replacement for this one if I don't like the performance of this one. So, speaker, everything is hooked up. Some of this stuff here. And we should be able to power this up and see if we get any radio sound now. I'm not sure about this thing. I don't know if this is supposed to be some kind of like coil tuner or what. Initially it was standing straight up like that, but now it wants to flop over, so I'm not quite sure what happened to it, why it doesn't want to stay in place now. So we're not sure if that's going to affect the performance or not, but for now let's just power it up and see what we get. I've still got the power switch bypassed since I haven't really looked into that yet. So let's plug this in and see what happens. So that tube's glowing, that tube's glowing. Don't really see any glowing from the 26s yet, so we might still have an issue with that voltage. Turn off the lights, let me see. Yeah, you can see not really any glowing from those. Those should be brighter than that. Should be going on. Let me check the voltage on those. So, stay straight. Check the here on the 26 volts. Turn on AC. Lights on so I can see what I'm doing. We are getting 1.2, so yeah, that's rather low, so I'm not really expecting much performance out of those. Let me check right over here. 1.3 there, so even that's low. Check from the bottom side. 1.5, so yeah, I think that this connection through here is not quite working properly. Could be because the bottom connection is actually riveted on the resistor on the bottom, so maybe that little bit of poor connection in there. So maybe I'll play with that for a little bit, but I definitely don't expect much performance when I'm only at 1.2 volts, and you really can't see anywhere. We can try. Not sure which way volume is. Actually, what we can do is we can try poking the grids and seeing if we get anything. A little bit there. Not much there. And basically nothing there. So yeah, I think that, let's see what happens. Yeah, so nothing there. Nothing there. Yeah, so I think that this voltage is not going to be good enough. So let me take a look at this connection again and see if I can figure out why we have such a significant voltage drop across there. Well, I jumped the wire across there, and now I got the voltage up to 1.38, so it's still a little bit low. I might have to do another solder a wire from here to there, just maybe poor connection like on the rivet on the bottom or something in there. I did notice that there seems to be a resistor from here to ground, so perhaps that half of the filament balance resistor went open on this side, so it may not even be important to leave that connection on the bottom anyway. Maybe I can just take the wire from the bottom up and solder it right up there. But anyway, for now, we got a little bit of voltage. I can see a little bit of tube glow. Should be able to see it or not. You can kind of see it going a little bit down there. Probably not optimal performance, but let's just see if we can get any sound now. I'm not sure which way is volume up, which way is volume down, so I actually don't even think I tested this control, so the control might not even be any good, but let's just see what happens. This tuning thing is not very fun. So I can't get an antenna, because I probably won't get anything. Antenna connected. That is this terminal right here. Antenna is connected. There's something there. Okay, so that was definitely volume all the way up. That wasn't any touching the antenna. It's pretty quiet. The antenna's not very long. Let's see if I can extend it a little bit. So I just added about another 6 feet or so to the antenna. So I've got my wires set up there well. Second station there. See if this makes any difference. Yeah, so poking that little flappy plate makes no difference that I can discern. Of course, we did change these tubes, so you never know that the adjustments in the front here might need to be played with. So actually probably would have neutralizing coils as well. So if we hear any howling, that means that neutralization is out. That's a fun process to adjust. Now we just try changing this front tube here with the one in the box and see if that improves the gain by any amount. Let's pop that out, and we'll pop this in. Yeah, it doesn't seem to make any difference. Well, that's about it. This video isn't going to have, superb performance, but it's just a TRF set. I don't think it'll be a little bit better than that, though. Let's try tuning in a station, and just for fun, we'll play with these trimmers in the front, see if that makes any difference.
Shelf for me, and then these ladies, one of them said, "Can you borrow for a minute?" And he opened it.
So it makes a difference when my screwdriver makes contact with it. Unfortunately, usually these adjustments are way too stiff to use a plastic screwdriver on. It doesn't make any difference at all. It was clamped pretty tight down. It doesn't seem to make any difference that I can tell. It doesn't seem to make any difference. We can try this next one here.
Things are changing, and then when you have all of these nightmarish things happening, also it just really doubles down.
That seems to have made a difference.
Even if things were normal, Phyllis, there would still be some significant changes with what you were doing with your money when you got to retirement, right?
So you're getting more stations now. Oh, on there.
About maybe after the drugs. We're going to be done by the thousands right now.
All who see that is Israel shall acknowledge them.
Holy cow. We should have just sent every person that was most threatened by this into isolation.
Signature dishes. To experience for yourself the Yow's difference, call them at area code 480-899.
Changed completely. It's no longer about.
Well, it seems to have done something. It's going to be kind of hard to adjust these with a little screwdriver though. These two first ones were cranked all the way down like super tight. I highly doubt that was the correct adjustment. I was suspicious of that. Yeah, let me see if I can take a look at this. You know what? I just realized something. I think I'm adjusting the wrong thing. Even though there's holes in the plate there, that might not actually be the adjustment. That might just be the capacitor hold down. So let me take a look at this because I see some adjustments on the back as well. Look more like, well, no, maybe those are the hold downs. Let me take a look at this, see if I can figure out exactly what I am adjusting, if I am adjusting anything, whether I'm just unscrewing the capacitors. Oh, we have an interesting development. I heard a little pop sound and the radio went completely quiet, and checking my B+, it was measuring like 2 volts. And now, if I check the resistance from the main B+ line from the other side of the transformer, see this? This is going right from the other side of this box here. From the output of that box to ground, I now have 111 ohms, which is way too low. Especially given looking at the schematic. Looking at the schematic here, there should be infinite resistance to ground because there are no ground biasing resistors from the B+. So you look, the B+ comes out, comes up and over and goes to there. See, it's labeled 135. That's the B+ there. Actually, I think a little bit higher than that. I don't know. I was just like 170 something. So that might be something to look into. Anyway, so that's the B+ there. And then that goes through a 50,000 ohm resistor down to here, which goes back over to this capacitor over here. So that's just, this capacitor just filtering post this dropper resistor. And then this dropper drop resistor here just goes to feed, goes all the way around down to feed this tube, which is the detector tube. Those usually run a little bit lower voltage, and just goes through the primary side of the audio coupling transformer, audio interstage transformer, to the plate there, and then has a little bypass capacitor there. And then the main B plus comes down here, goes to this 0.25 filter capacitor, and then it goes up through coils to plate, over up through coils to plate, through coils to plate, coils to plate, over through audio transformer primary to plate, through speaker to plate. So there's no resistor from B plus to ground. So there should have infinite resistance when the radio is off and the tubes aren't conducting. So clearly something has shorted. I'm going to clip the wire that goes through this loom here. I'm going to clip it right here and see if the short is in the power supply or if the short is here in the chassis. So let me get my clips here. Just clip that off. It's not a very, wire's not in very good shape anyway, so probably should have. So I can get that out of the way. And now, so I'll see my meter there. See what our resistance is from here to ground. It is all over the place. Make sure this is not interfering. And it's all over the place. Might be a capacitor still discharging or something. Definitely a change. We can check the resistance on this side now from B plus to ground. 77 ohms. So yeah, definitely the short's in the receiver plug. So the power supply should be fine. Hopefully we didn't burn anything up. I can probably check that now. If I plug it in now and check what the B plus voltage is here, it should be pretty high, but actually I really don't think I want to do that, because on a lot of these old radios, the capacitors were rated pretty tight tolerance to the voltage they were expecting them to receive. So at least in a couple service manuals I've seen for like the late 20s radios, they specifically tell you don't power up the power supply without the receiver attached, because without the receiver drain, the open loop B plus will drift higher than the capacitors are rated for, and we don't want to blow up any capacitors inside this tin box here. It's actually a little bit warm. I would rather like to not have to rebuild this tin box. You can see it's full of tar, so this is not going to be fun to melt out. If it was like the yellow wax, it'd be a lot easier. You can just put those in the toaster oven and they melt right out, but this stuff is usually much harder. You can see it's a much harder substance, and usually they melt at a much higher temperature, and I think they're pretty stinky too. So I'd like to not rebuild this if at all possible. So anyway, time to go short hunting in the chassis. The first thing I'll do is pull out all the tubes. They shouldn't affect anything, but just get them out of the way. Put them in hopefully a safe place so I don't damage any of them. Messing around here. These tube sockets are not exactly confidence inspiring. As I got a tag on it. Something in 1933. ABC Shop, Massachusetts. Okay, so all the tubes are out of the way. I shouldn't have changed anything, but just for fun, I can double check. Still seeing 77 ohms, so let me disconnect all of my conglomeration over here to make sure that's not affecting anything it shouldn't be. $81. Could just be a change because now this is not connected the same way. There we go, 77. So before, when I put the probe, you can't really see what I'm doing. This is not a very good viewing angle. When I put the probe in here, this clip was clipped on the bottom, so I was resting on top of the clip and making, pretty good contact with the shiny surface on the clip. Now that I took it out, it was just not making as perfect contact. That's why the resistance went up for a second there. But so okay. So what we can do is let's get this out of the way. Possibly dead one out of the way. We can flip this up and take a look. Suspicious points would probably be that 0.25 capacitor. See if we can find that first. I've got my probe lead tangled up in the antenna. Let's take the antenna off for now. Really need that at the moment. There's the antenna. We can flip this up maybe. Just rest it on that tin. Should be hopefully fine. That guy is probably it right there. See that? It's kind of in the way. So I think it's actually the first time I've shown the bottom of this thing. Our switch out of the way, you can see the wires here are not exactly the best. This is that capacitor somebody tacked on here. I think it's some rudimentary form of AC filtering. Let's clip this wire out of the way. You can see how bad all the insulation is on these, so that could also be a potential point of failure too. So let's see. So this is probably that capacitor. They didn't bother labeling it from what I can tell. So what we can do, actually no, that looks like it's on the filament supply. So one side goes to the filament supply, and the other side looks like it goes to the filament supply. So that's just a capacitor across the filament supply, as far as I can tell. So that wouldn't be it. The rest all look like these microcapacitors. They wouldn't be that high voltage. So unless somebody did some massive changes in here. Let me take a look at this for a minute, see if I can trace out where the B plus is going, because it's coming in. It's coming in this line here. It's coming from this point. So this point probably the B plus right here. A line will go to here. Oh, there's a third wire going to this capacitor. So this is that guy. That's what I thought. Looks like there's two ground lines and a. That's interesting. Unless there's multiple capacitors in there. Take a look at the schematic. It didn't look like it would be that way. So this should be that guy right there. The B plus comes in right from that point, right down to that capacitor, which goes to ground. But for some reason, it looks like there's two grounds coming out of it, one going to one side of the 1.5 volt filament supply, one going to the other side right there. So that's interesting. I don't know why they didn't tie it directly to chassis ground, but either way, we'll just try clipping this lead here right off. It's pretty crunchy too. Now let's see if it made any difference here. So from here to ground, Okay, looks like we now have nothing. If I get on the end of this lead here, expose some of the wire. So if I go to this lead, it's also showing nothing. That's interesting. Oh, there we go. 79 ohms. Yep. So looks like that capacitor just shorted. Alright, so should be a quick fix, I think. I have some of those available, not 0.25 but 0.22. So we'll just suppose what I could do. I'm not even sure how this is going to work, because I've got these two wires coming out. So I'm not sure if there's a capacitor to either side, or what the deal is. I might even have to take this out and have a look at how it's constructed, just to see how the capacitor works with these two separate black wires coming out of here. I'm not sure if they've got like a 0.25 to either side of the filament winding, or it almost have to be that way because you couldn't short these two together. So we'll try that and see if that works, or I might just try going directly to ground like the schematic says. This could be a little bit of a design illusion or something, but anyway, looks like we found our short. So let's see if we can replace that. You know, the more I look at this thing, it looks like someone's done some kind of shoddy work on it. You can see over here, this red resistor is probably a factory original. You can see how it's wrapped around and riveted in. It's actually wrapped around the rivet studs. This resistor was riveted in when the tube socket was put in. Now if you look at some of these other ones, so right here for example, you can see there's a different style. It's kind of like this round ribbed resistor, and instead of the round with one flat spot on the side that the old ones were, octagonal or whatever they are. Looks like they were just round with one flat spot on the side. You can see this blue one over here is the same style, wrapped around and soldered, versus these ones which are a different style. You can see this kind of laid it across and kind of melted up the solder a little bit, and then just kind of stuck it in the solder. You can see the solder is not even totally wrapped around the lead. This one down here is a pretty, see that, so this one down here is a pretty crappy joint too, right there. My tripod doesn't stay in position anymore. This is a pretty crappy one too. So I was like, at some point someone has gone in, installed these three different style resistors. This one's also not so hot. It's a little better than the other two, but it's not so hot. So perhaps they installed this capacitor as well as a little later modification or something. If you look at the solder joint on there, you can see how all the wires are like all spread out and all over the place. So they just tacked that on too. So actually, yeah, because the original wire was crimped and riveted on, was put in like a crimped eyelet and then riveted on. So yeah, definitely these were hacked on later. So I'm starting to wonder if maybe the original one, and of course then there's this hacked on mess here too, off the power switch. I'm wondering if the original one was just gone straight to ground. Maybe this looks like it might be a ground terminal, actually no. Yeah, maybe, this might be a ground terminal here even. So now I can just put a capacitor from here to ground and see what that gets us. Maybe this was an attempt to reduce some of the hum. I really don't know. Anyway, I think I'm going to try just going from here to ground and see what that gets us, because this is definitely not a quality installation job on that. Okay, so the new capacitors are installed. I did figure out how those, or what the other two wires were for. So if you look here, there is a 0.1 to ground off either side of the filament supply. So that's where those other two wires were going. So this box here actually has three capacitors in it. it has the 2.1s for either side of the filament, the 1.5 volt filament, and then also the 0.25 for the B plus filter. So I've got my 2.1s here from either side of the filament, and my B plus filter 0.22 here, and then these just go up here, which goes to this convenient ground point. I just wrap the wire around that post and bolted it back down. So that's going to be connected to ground. I verified that our resistance on the B plus line is now infinity, so we can try this again. These resistors, I think are supposed to, if you look at the schematic here, they say 1000 ohms. These all are labeled 750 on these little tags here. You can't really, that one you can kind of see. So 750 on the white part of the tag. Why they didn't put the right value in, I have no idea. We're just going to leave those alone for now. I don't think that was the source of our problem. So we're just going to ignore those for the time being. I am considering replacing this wiring harness, because you can see how cracked the wires are coming out of it. So might be a good idea to replace this at some point. But for now, let's just flip this back down and see if it will still work. This whole wire right here. Oh, there's something else weird that I wanted to point out. I cannot find the volume control anywhere here on the schematic. It shows it on the diagram right there where it is, but I can't find it anywhere in circuit here. Looking at the wiring, it looks like what they're doing, and you can see the wires here coming out from the volume control. This one here goes to the B+, which runs down here to this B+ junction there, and then the other pink one goes over here. This is the plate terminal of the third RF tube, and what it looks like they're doing is it looks like they are shorting out the primary side of the RF coupling coil between these two tubes, which on the schematic would be right here. So it looks like the volume control goes from B+ here to plate of the tube here. So basically there's a resistance, a variable resistance connected from B+ to the plate of this tube. And it looks like all that would do is like basically short out this RF coil here. That's very weird. I've never seen volume control done that way before. These are pretty low resistance coils here, so I'm not sure how much effect that would actually have. It's a little weird. It looks like that's what they're doing. I'm not sure if that was original or not. It looks like it was original, because everything is like nice and neatly, connected to the riveted points and everything. So, yeah, it's kind of weird. Anyway, let's flip this back down. Everything's out of the way. Should be able to reconnect everything now. To reconnect the speaker and everything, and then I'll put the tubes back in. And we got the tubes. I'm not sure if that one with that that I've taken out for the moment is actually going to be any good or not. the globe one. I might try putting it back in to see if it makes any difference, assuming this actually works. This socket is actually working properly. The tube is actually right up against the end of the tuning shaft there, which is kind of weird. I'm not sure why they've done that way. Could be because these ST types are a little bit fatter. You can actually see what I'm talking about here. So I push this all the way down in, it hits against the end of the capacitor shaft there, so I have to tilt it to the side a little bit. And it could be because the ST type tubes like those are a little bit fatter in the middle instead of fattest at the top like the globe ones are. So I might try the globe one here to see if it'll work. Anyway, set that back up. And just double check that our B plus is no longer shorted. So from here to ground, I should have nothing. So charging capacitor 10, 11 mega ohms, 12 mega ohms. So that would charge up that capacitor. Well, you know what else I forgot to reconnect this wire over here. So let me do that real quick. I forgot to reconnect the B plus wire that I clipped off the power supply. So I have to do that, and then we can try powering this up. Okay, so B plus wire is reattached. You can see volts. We'll plug this in and see if our B plus drops to 2 volts again. Hopefully it won't. There's sound of the speaker again. 135, that looks better. Well, those leaky capacitors replaced, maybe our filament voltage will come up a little bit too. I'm not sure if those capacitors will be leaky enough to draw it down. And find out. Go to AC. So our filament voltage is now is low. Lower than it was before, that's interesting. Barely see tubes line. .2 right off the power supply. What about down to here? 1.4. Let me put that bumper back. I don't know if that was helping or not. Let's go right from here to here. .35, still kind of low. Let me reconnect the antenna. Antenna is reconnected. Volume control, I think, is up. And we've got radio again. That's some cracking, I'm not sure. It's like that 2 socket may not be so great. And I've double checked these. I don't think these are adjustments. I don't know if this same plate was used for another radio that had adjustments in the front, or whether this one was intended to and they just never put them in. But looking at this even closer, I don't see any capacitors down in there. I think these are just the screws holding the tuning capacitor in place. There's something on the back that may or may not be adjustments. I don't know if I really want to play with them though. Stupid. Maybe a little bit louder than it was before. I don't remember getting quite so many stations before. works. Yeah, it does. So that weird way of shorting out that weird way of shorting out the primary of that one RF coil seems to be an effective volume control. So never seen that done before. It's weird.
Well, there are almost two cells about to say each something like if I can be a cheesecake, right? This cheesecake factory, there is no way that I can.
Well, maybe not. It doesn't go down all the way. That's volume at its minimum is that loud. So that's not exactly pleasant. I think it would be able to go down a little bit lower than that, because I don't think that's like a super strong station either. I don't think that's the strongest that I get here, but that's interesting.
Sheet from a load supporting wall, and I don't know if I can just patch it or if I need to put a support beam.
Oh, that's way too loud. So that's volume all the way at the minimum, and that station is like just blasting out of the radio. So maybe that weird shorting out the RF primary is not exactly the best way to do volume control. Anyway, let's tune back.
That was in 87.
Oh, maybe it's just a dirty volume control or something then. That's the minimum. Yeah. Okay. So that was the contact meters. Anyway, I'll have to clean that volume controller once I find out what happened to my contact meter. But it seems to be working now. Getting a not too bad number of stations. And just a basic TRF radio, and I don't have the ground connected, just the little, I don't know, maybe 15-foot antenna-ish connected to it. So I think I'm going to be okay with that actually. That performance seems appropriate for this type of radio. I wouldn't expect anything magical since it's just a TRF set. It's a little bit better than most TRFs because it has an extra RF stage. So anyway, check this voltage out to see what we're getting now.
Turns out a lot of holes.
1.3. Clearly that injects quite a bit of signal in there, so I won't do that for long. So that's still a little bit low. And there's something else I wanted to check as well. Because if you look at the schematic here, this is the resistor here, the filament balance resistor. So you can see that the 1.5 volt winding here, either side of that goes over to either side of this resistor, and then again either side of that goes over to either side of the filament tube. So this resistor is basically connected in parallel across all of the tube filaments, all these 26 tube filaments, and then it has a 150 ohm resistor out of the center tap to ground. And the point of this is because this is an AC supplied to the filaments. The point of this is to keep the filaments balanced across ground, because these are directly heated cathode tubes. So the current flowing through the tube goes directly to the filament, and then that goes back to ground. And if you had just connected the resistor here to one side, like if you just connected ground here to one side here and got rid of this resistor, then you'd have a massive amount of hum, because this other side of the filament would be constantly going up and down, 1.5 volts positive, 1.5 volts negative with respect to ground. So you get that 1.5 volt hum going through all these tubes, which would not be exactly pleasant. So they attach ground to the middle here so that either side of the filament is balanced across ground, and then basically essentially the center of the filament is kept at the same potential here, is basically the idea. And then this 150 ohm resistor is just the grid bias resistor. Because the grids are all connected to ground, this provides a little bit of grid bias so that the cathodes are sitting at a DC potential a little bit above ground. So all the current flowing through these tubes comes back and then it flows through either side of this resistor. Then all that current flows through this 150 ohm resistor to ground, and then that develops a little bit of DC bias there for the grid bias. Anyway, my point was that this doesn't exactly seem the way that it's shown on the schematic. If you look here, I've got this jumper across here. I think that the riveted connection on the bottom might be a bit bad and not making perfect connection from the riveted terminal on the bottom all the way up through to the connection on the top. I've already cleaned this one on the top and that made some improvement, but my point is there's a resistor going directly from this terminal to ground. Now, that's not the way it's supposed to be. The resistor is supposed to be going from the center top of the resistor to ground, but it's not. It's going directly from this terminal. So that could be the reason why we have a bit of hum in the output, a little bit more than I would expect for something like this. It could also be that the capacitors in there are weak, but I'm trying as hard as I can to not touch that. I really don't want to have to dig all that tar out of there. So I might do a little bit more of an investigation on what the heck happened here, and as you can see, or not see, this is one of those later style Rively resistors with a little paper label on it. So this may be another hack repair at some point, maybe by the same person that whatever happened there. So might require some further investigation. At any rate, the radio is working for now. So I think I'm going to call this part 2 of this. The switch does seem to be working now. I just took the jumper off and gave a couple of flips back and forth, and it seems to have come back. So I'm going to leave that alone. We're going to have to investigate that terminal a little bit further. We're going to have to investigate the biasing of the 1.5 volt filaments a bit further, and potentially replace all of these wires in the wiring harness. You can see these ones here too are pretty cracked. Now these go right into that block, no terminals, so I don't know if I'm going to mess with those. They really shouldn't have any flux to them. Of course, this thing gets fluxed every time you move the radio, like every time you take the radio in and out of the cabinet, and I will have to flex it again to put the radio back in the cabinet, so it might be worthwhile looking into replacing some of these. You can see some of them aren't too bad, like these ones here look perfectly fine. I don't see any cracking at all. But if you look at these green ones here, they look absolutely horrendous. Almost look like someone used marshmallows or something for insulation on those wires. So, might look into replacing those. But for now, the radio is working. I will call this part 2. And there may be a part 3 of going through and replacing a decent amount of the wiring work on this. And we'll also have to figure out how to mount that choke in the cabinet so I can use this speaker with it. I'm not going to invest in another speaker just for this radio. I'll just mount that little choke somewhere in the cabinet. Hopefully non-destructively. Hopefully I can use some existing bolts and I won't have to drill any new holes. But we'll get into that into the next part.
I would like to say that.
For what? I'm not talking about.
You also need to have to get into something to do with this too. You see, someone's just wrapped the rubber bands around it, but they didn't do it quite evenly. So that's why it slips sometimes. There's a point where the rubber bands are tighter and a point where they're looser against this friction wheel here. So you can see all that does is, as I turn this, the friction of the rubber bands against that wheel are all that drive it. And see, now it's slipping. Now it gets to a tight part, it starts going again. So I'm gonna have a look into that too. I do think I did find the original piece
Space for that jumping jack.
in the
And,
cabinet.
I'm not a fitness guy, alright? But we make so many excuses for why we aren't
Let's tune to something a little bit quieter
what we're
here.
supposed to be doing. Or is I strongly ask that you don't know what you're not doing.
This I think is the original piece. I found this in the bottom of the cabinet. Looks like this might have been bolted onto that shaft. And you can see it's all misshapen and lumpy. So that might be the original. Or maybe that was someone's first attempt at replacing it. I don't know. Quiet. Anyway, so that one had to be looked into too. See if we can figure out something else to make this a more reliable tuning experience. But for now, the radio is working. That's going to be it for this part. So I hope you enjoyed this video, and thank you for watching.
Really see past your eyes. And oftentimes,
Permitted to, and then you would exit out another entrance, and then you have pieces on the floor where you stand.
That's way too loud. There's other something's up with this control here.
Jesus spoke with him.
What's up with that tube socket too? Anyway, still a few kinks to work out, but hopefully we'll take care of those in the next part.